love to move on to our first speaker, who's Erez Galonska. He's the co-founder and CTO of a business called INFARM, which is probably one of the most exciting companies out of Berlin and soon to be out of Europe. They're working on vertically integrated farming. And so he's an inventor, self-taught farmer, entrepreneur, and I can't wait to hear what he's up to. So, Guy, over to you.
Thank you very much. Yeah. Okay. Is this on? Yes. Thank you, Nathan. Nathan and family, I should say. Really excited to be here and open this fourth summit. INFARM started 5 years ago with a mission to transform cities and how we grow food. It started from a personal passion of also a family, me, my brother, and his partner. We moved to Berlin 5 years ago from Israel to develop indoor farming systems. Try to bring this countryside feeling of just picking a plant, eating it, into the modern city life. So I'll tell you a bit about INFARM and then dive a bit into how potentially indoor farming and INFARM in particular can really change agriculture and help scale to 10 billion people, basically. So some of you might know the extremely complex supply chain of modern agriculture. It's a huge network of connections. Our food really travels thousands of kilometers before it reaches our plates. But unfortunately, along that way, it loses much of its nutrients and health benefits. Of course, taste is also something that kind of falls behind with the truck. Farmers today harvest as fast as possible, put it into huge cooled warehouses, go into sorting machines, packaging machines, another cooling location, low oxygen environments, goes into another cool truck, which goes into a cool distribution center, which goes into a cool supermarket, which finally you go in the supermarket, which is also cooled, and you buy it and put it in your fridge. So extremely wasteful, not an energy actually that you can see, but it's definitely there. INFARM tries to change this by growing food in the city and enabling a biodiversity which is today not really possible. You see, most of our food is grown in several Mediterranean locations and being shipped to wherever it's consumed. So food here in the UK is mostly coming from Spain, south of Spain. Also North America and Israel, big exporters. A quick survey we did here in the UK found an interesting potential, which is true for all the other places we did this survey at. So 50% of people say they want to have local food. They would rather see the food they eat grow. I think that's kind of a no-brainer. And if you would probably explain why it's better to eat local food, that number would probably go up more. But then 70% of those people want to eat exotic varieties. So here we have this kind of gap where, at least in Germany, if you're going to eat local, you're going to eat cabbage, potatoes, maybe 3 different kinds of potatoes, kohlrabi, which I don't think it has an English name even. So not very appealing. Still, you would want to eat local, but you really want that avocado or Genovese basil or tomatoes from Napoli. So that's a huge potential which INFARM is kind of going at by offering locally produced food from around the world. We do this by offering what we internally call farming as a service, or FAS. And we do it in 3 different ways. Growing in your location, We target mostly supermarkets and retailers now, as they're big and they have a need. That's kind of how a farm looks like in a supermarket in Berlin. It's kind of like a big fridge. It's a controlled environment unit. We're able to control the lights, the water, the fertilizers, the ventilation, lots of environmental sensors that send us data that helps us optimize the growing conditions. For retailers today, brick and mortar, they are kind of fighting the online world, which Amazon Fresh and Ocado here in the UK are biting their revenues quite aggressively, actually. So they want to enhance the customer experience in the shop and make you come there again. Probably not going to help, but still INFARM is there to build them indoor farms in their locations and provide them this nice experience. When our growers go to pick up the plants and put them in a point of sale, the entire supermarket smells like basil. And this is really attractive. You probably never went into your local supermarket and smelled the herbs. This is something an INFARM system does. That's how it looks like, together with a fancy point of sale. We use paper packaging. Everything is recyclable and sustainable. The farms are extremely productive. From a 2 square meter footprint, we're able to produce over 1,000 plants a month, which means 1 or 2 units in a supermarket is actually sufficient to supply most of the kind of normal herbs, like mint, basil, chives, and all that. The second option we offer is to build larger scale farms in distribution centers, leveraging retailers' existing logistical networks. So we would build a larger scale with actually the same kind of unit, this modular vertical farming building block, and distribute using that network to locations. That gives, of course, more efficient operations, so slightly lower price per plant for the retailers. And the final farming as a service variation is we grow the plants in our locations, in our hubs, and deliver them directly to you. We work like this with a few restaurants in Berlin and all our retail locations. And this works quite well together, actually. So most of the locations would have an in-store farming unit, a point of sale, and we would then augment that point of sale with extra plants coming from our locations. So if on location we grow 3, 4, 5, 6 varieties, we can bring another 10 from our locations. So the model works very well and creates kind of a network that works together. Currently in Berlin, we're in about 25 locations, supermarkets and restaurants in the city, with about 70 farming units like those that you've seen. Berlin has been our kind of a pilot project for the last 2 years, which is very nice that we can experiment there. Probably would not have worked in London. We had, of course, issues at the beginning, which we had to overcome. And Berlin is very tolerant of this. So the plants themselves, and I wish I could have bought you some, are extremely tasteful. And this is something we were kind of skeptic. We come from the village in Israel. We used to grow our own food, also traveling around the world and working in farms, in permaculture farms. We were not sure we were going to grow good plants. Like, there was this kind of mindset that said hydroponic plants and indoor farming plants are not going to taste good. So we tried it ourselves first, and we were pretty amazed, and that's kind of how we started from our living room. So the plants are really, really good, have extremely, they're crunchy, they're flavorsome. You can really feel, oh, okay, that's the true flavor of mint. And in Germany, actually, some of the plants are too strong for the market. And also for me, sometimes it's coriander is a bit too strong. And that's actually probably one of the reasons we managed to close our Series A 8 months ago. We just came with boxes and boxes of plants and put it on the partner's table, hand it out, and that closed the deal. So they're pesticides-free, non-GMO, and come in a huge variety. See, part of this lengthy supply chain of agriculture makes it very hard for farmers to grow a huge variety of plants. However, this huge variety exists. There are hundreds of basil varieties. There are thousands of lettuce varieties. And that's true for every kind of plant. Your farmer in the Netherlands or in Spain, actually, with acres of greenhouses, it's much, much easier for them to grow one specific variety under the same conditions, grow it all at the same time, harvest everything at the same time, put it on the same truck, send it to one location, and start again. Imagine this process with 300 different plants. Logistically, it's just extremely complex, non-efficient, and not economical, and not possible. That's why you have only one basil or just 2, 3 kinds of tomatoes in your supermarket, although in reality there's thousands. So we're all missing out on something really great. What enables us to grow these plants is controlled environment agriculture. Each farm, as I mentioned before, is controlled. We can monitor it, and we can really fine-tune the growing recipe for the different plants. All of this leads to a trend, which is kind of a mega trend, which you all know, of personalization. Personalization is happening anywhere, in your apps, in your Google News stream. I had my guys briefing for today. It's also happening in food. And we believe in-farm and indoor farming in particular is actually able to do that. Today, we're doing personalization on a supermarket level. So the supermarket in East Berlin is growing different varieties than the supermarket in West Berlin. Totally different demographics. But we're also able to do that in the near future directly to you based on your diet, based on what you prefer to eat, or perhaps what you need to eat. Okay, this was the marketing part of the presentation. And a bit about the hidden side of INFARM and the potential of big data. I call this the perfect recipe, which actually doesn't exist, but I'll show you what I mean. So a bit of what we're trying to create using machine learning and AI. When a farmer picks up a plant, they know so much about this plant, and in an instant. They know what's the issues, if there's any disease, if there were pests on it before. They know what needs to happen. Oh, should give a bit more water, or should put it more in the shade now. And of course, this happens in an instant. The wonders of the human mind, which allows us to take all this vast experience and associations, even though without many repetitions, right? I mean, farmers would grow just thousands of plants in their lifetime, like plant cycles. Not a lot. Farming 10,000 years ago and farming today has been about 30,000 cycles of wheat growing. That's not all that much, considering there's almost no connection between farmers. So that's kind of what we want to create. Now, agriculture research is extremely, extremely slow. The reason it's slow is because, of course, plants take time to grow. Wheat takes 3 to 4 months. So if you would do research on wheat, you would grow them in one of those fancy chambers, which are very similar to our chambers, just a bit uglier, and they cost between 100 to 200,000 euros. Ridiculous prices, sold to universities. Biggest universities would have 20 to 30 of those units, and they would be shared between all the different PhDs and master degree students. So the research is really, really slow. Of course, it's underfunded compared to all other tech we all know. And it takes a long time to get the repetition needed to gain meaningful insights. Plants are extremely complex, which makes it hard to get those meaningful insights. So plants, of course, are adaptive, and they come like humans. They're the sum of their interactions. And you have pH, temperature, fertilizer levels, light intensity, the light spectrum, the light duration, relative humidity, CO2, even neighboring plants, thousands of varieties of bacteria and fungus, most of which are uncategorized by science, insects, the genetics of the plants, endless, the list of variables that affect plant growth and plant quality. This, by the way, our patented growing tray, allowing us to kind of harvest the outside of the tray. We turn it, the plants go out, and we put more plants in the middle based on the sunflower. And this kind of brings us to something you all might know, which is a relatively simple kind of reinforcement learning loop, where our farms are sending environmental data all the time, observations, temperature, humidity, fertilizer, all that, sent through our controllers. Each one is IoT connected and so on. The controller then can influence the different actuators, whether it's small pumps to adjust the acidity levels, the fertilizer levels, add water, change the lighting schedules, and so on. And this is really not new and happening in greenhouses all over the world. That's really much of a head grower's job. Look at the observations, make the corrections. What we're introducing now in the last months is measuring bio outputs, and that is monitoring live on the quality of the plants. That could be photosynthetic activity, growth rate, size, leaf area. And that allows us to kind of close that feedback loop into potentially self-optimizing farms. So imagine we grow, again, basil in this farm, and let's say I want to have the perfect recipe to grow 30-gram basil with the greenest color. So giving that mission to the controller, then it can start making those different corrections. With the bio outputs as kind of the reward system for that algorithm. Some examples of these bio outputs that we're integrating now. This is from one of the farms in camera, where we are able to monitor the growth, get the leaf area of the plants. And we can get many interesting things with camera vision, kind of the farmer's eye. So yeah, leaf area, plant height, plant growth, the color index. We can understand various nutrient deficiencies. So if plants go a bit yellow at the top, that would mean a nitrogen deficiency. If it go yellow in the bottom, that would be a magnesium deficiency. And we can really understand these things, and it tells us a lot about what we do right or wrong. Another very interesting biofeedback is an interesting experiment we've been doing. And what you see here is just CO2 over the day. And you see those dips going down. That is when we turn off the fans in the farm, the intake and the outtake. We just turn it off, and we see how long until the CO2 is consumed in the system. If we zoom into one of those dips, it kind of looks like this, where you have the different measurement points. That's when we turn off the fan. That's when we turn it back on. And very easily we can calculate the slope of this change. What this gives us is a photosynthetic activity index, giving us real-time understanding of the plant's health. Plotted over time, we can see how the photosynthetic activity changes throughout the day. Now, what's interesting is that the growing conditions in the farm are the same. So the plant, this is the natural cycle of a plant's photosynthesis activity. This means that we can do really, really amazing things now. So suddenly we don't have to provide lighting all day long in the same intensity. That does not make sense. So here we can reduce the lighting by 90%. Of course, in outdoor, maybe that's not so important, but indoor, where electricity is expensive, this can be huge, huge saving for resource, but also economical. We believe this by tapping into the plant's live stream, we can really have the plants control the farm and not us, allowing them to bloom into their full potential. So each farm is kind of an experimental platform. We get all this data. We track it from day one. We have over 10,000 data points on the environment and plants during their short time in the farm, which is between 3 weeks to 4 weeks. And we can really get all this interesting data. But as you know, to train these algorithms, we need lots of repetition. And that's where we are kind of differed from our competitors, which some of you might have heard. Many of them have raised insane amounts of money to achieve their goals. And what they do is they build kind of big box indoor farms, 2,000 square meter, 3,000, 6,000, huge indoor farms, not really different than your normal greenhouse, actually, just with lights. And they don't have this granularity and compartmentalization that we achieve with our network. So now imagine this, that each farm is a research platform. If you multiply it now by the 70 farms we have in Berlin, we're going to have about 300 Europe-wide at the end of the year and thousands in 2 years. You get a lot of data. Now, what if I start playing just a little bit? So I would change the temperature by 0.2 degrees here and there. I can do massive parallel experimenting and understanding and start to understand the different mechanisms that make plants grow and why. And this is something that is in the agriculture research really kind of unheard of. So what are we going to do with all this data? Which I think is an important question because, okay, we have lots of data. Lots of farming companies would say they have lots of data, but then what to do with it is probably the main question. The obvious one would be for INFARM to improve dramatically the plant quality and the plant output, so we can offer better plants for all of you. Slightly less known is maybe the pharmaceutical industry, which use active ingredient mining in plants. Most of them have indoor farming facilities, cultivating plants for the different useful chemicals they have in them. So using this kind of perfect recipe system, we can do research for them to increase the output of that specific chemical and give it a kind of a consistent yield. This pharmaceutical today also mean, of course, cannabis, which can benefit quite a lot from this kind of technologies. And the last part, which is maybe the most exciting and that can have the most impact on humanity, is partnering with field farmers and your greenhouse farmers. much of the criticism indoor farming gets, oh yeah, but you think you're going to grow rice and wheat and corn? Not necessarily. But the data and the research potential of indoor farming can actually help farmers increase their output dramatically. So I call this the perfect recipe, but actually what can be very useful is also the non-perfect recipe. So if we know what is the optimal way to grow high-yield wheat, that also means we're going to know that if you're going to have a 32 degrees full-on sun for the next 2 days, that's going to have this and that impact on your crop, and this is kind of what you should do to reduce the stress on the plants. This can have huge, huge impacts on farmers' life and revenue. I'd like to finish with the mission, actually, and that's the mission of the R&D teams at INFARM. And we have 5 points which we try to stick to. And the first one is, as I mentioned, create the infrastructure for personalized farming, allowing really personalized food to come into our life very soon. 2 is to grow the highest quality produce to enhance the human condition. They say you are what you eat, and we think you should be the best, so we're going to try to grow the best. Foster true sustainability and alleviate the effects of humanity on this earth. I don't know how much you're following this topic. You probably are, because it's probably one of the biggest challenges of us as a species on this planet, facing exponential population growth. Develop, of course, economical products and services, otherwise I won't be here. And ensure the scalability of the product across the organization. That is hardware, software, and everything around it. So finishing with a Berlin cliche. Thank you very much, and hopefully see you soon in the UK.